So I guess we are live and I think we are good to go, right? So,
Yes, yeah.
all right. So, welcome everyone. Welcome to another episode of ML Talks. For those who don't know, ML Talks is even that the ML team at GDSC takes. It is a bunch of live streams that we take, and it is basically held to help you guys learn machine learning and get advanced in deep learning and stuff like that. So we are done with episode number one. This is episode number two, and Jackson will go ahead and explain you what we are going to do in today's session. Without wasting time, let's just dive right into it.
Yes. Thank you, Ayush. Evening, guys. I'm Jackson Jacob, ML co-lead at GDSA VIT Bhopal. And in this session, we'll be covering what is deep learning, how did deep learning come into existence, various components of deep learning, and we will learn about a tool called TensorFlow, which will be used to uh, interpret learning, and then later we will be creating our own neural network from scratch. The outcome of this session will be to get you guys started with deep learning as soon as possible so that you guys can get started on this journey. Okay, so let me share my screen and we'll be good to go. Great, I think my screen is visible, so we can go forward.
Become increasingly popular thanks to abundant data and increased computing power. It's the main technology behind many of the applications that we use every day, including online translation and automated face tagging in social media. Deep learning is a subset of machine learning, a branch of artificial intelligence that covers computers to perform tasks through experience. Machine learning algorithms previously developed their behavior by processing annotated examples through a process called training. For instance, to create a fraud detection program, we trained a machine learning algorithm with a list of bank transactions and their eventual outcome, that is legitimate or fraudulent. The machine learning model examined the examples and developed a statistical representation of common characteristics between legitimate and fraudulent transactions. After that, when we provided the algorithm with the data of a new bank transaction, it classified it as legitimate or fraudulent based on the patterns it had learned from the training examples. The more quality of data that we provided, the more accurate a machine learning algorithm became at performing its tasks. While classical machine learning algorithms solved many problems, they were poor at dealing with soft data such as images, video, sound files, and unstructured text. For instance, creating a breast cancer prediction model using classical machine learning approaches would require the efforts of dozens of domain experts, computer programmers, and mathematicians. The researchers would have to do a lot of feature engineering to provide known patterns in X ray and MRI scans and then applying machine learning on top of the extracted features. Creating such an AI model would take years. Next slide. Deep learning algorithms solved the same problem using deep neural networks, a type of software architecture inspired by the human brain to find associations between a set of inputs and outputs. A neural network is composed of input, hidden, and output layers, all of which are composed of nodes. Input layers take in numerical representation of data, that is, images with pixel specs, output layers, and output predictions, while hidden layers are correlated with most of the computation. The goal of any neural network is ultimately to minimize this loss by adjusting the weights and biases of the network by using something called as backpropagation through gradient descent. The neural network backtracks through all of its layers to update the weights and biases of every node in the opposite direction of the loss function. In other words, in every iteration of backpropagation, it results in a smaller loss function than before. The continuous updates of the weights and the biases of the network ultimately turns it into a very precise function approximator, one that models the relationship between inputs and expected outputs. In this slide, we will be understanding why people are preferring deep learning compared to the old machine learning algorithms. A look at some of the points are: deep learning works with both structured and unstructured data. Deep learning algorithms, on the other hand, also perform complex operations very efficiently. It also accepts large volumes of data as input and analyzes the input data to extract features out of an object. It, the deep learning model's efficiency also doesn't decrease while dealing with large datasets. Thank you. Over to you, Hemant.
So now let's talk about applications of deep learning. Speech recognition. A good example of speech recognition is when you take out your phone and call out "Okay Google." Imagine writing a program to respond to the vague words such as "Okay Google" would be very tedious. There would be a lot of physics involved. That's why we use deep learning to make this task easier. Next slide. Deepfakes. A few days ago, I was playing with this app called Wombo AI to generate lip sync videos. I input any image and the app would make it sing. Really, a good use of deepfakes can be seen here. Self-driving cars. Uh, how cool it would be to sit and relax and watch your car drive. Tesla, Waymo, and many more companies have made excellent progress in this direction that enable at least partial autonomy. Remember, full autonomy is not quite within reach yet, since it is very challenging for proper driving. Now, let's talk about neural network and its applications. Neural networks are networks that utilize complex mathematical models for information processing. They are they are based on the model of functioning of neurons and synapses in the brain of human beings. It receives data input and then combines the input with its internal activation state. Then, by using an output function, it produces the output. Neural networks consist of artificial neurons that are similar to the biological model of neurons. Before understanding what is an input layer, let's know what is a layer. Simply, we can say that the layer is a container of neuron. In these layers, there will always be an input and output layer, and we have zero or more number of hidden layers. Input layer. The input layer is responsible for receiving the inputs. These inputs can be loaded from an external source, such as a web service or a CSV file. The input layer of our model is in orange. Um, Learning. Hidden layer, sorry. Hidden layer resides in between input and output layers, and this is the primary reason why they are referred to as hidden. The word hidden implies that they're not visible to the external systems and are private to the neural network. Our first hidden layer of neurons is in blue, and our second hidden layer of neurons is in magenta. Learning. Learning is the process by which the network adapts itself to handle the task better. A learning rate can be simply said as the size of corrective steps the model has to take to adjust its errors. A high learning rate does not mean that the model would train faster, but what it actually means is that the model will jump very far away, giving less accuracy. So, in practice, keep this learning rate low so the model would take small steps and arrive at the least error. Uh, weights weights are the real values that tell us how important the feature is, and bias is used to shift the activation function. Uh, cost function cost function in simple terms measures the performance of a neural network model. We want to find the set of weights and biases that minimize the cost function, where the cost function is an approximation of how wrong our predictions are relative to the target outcome. Forward propagation. Forward propagation is the process of moving forward to the neural network, and the objective of forward propagation is to calculate the activations at each neuron for each successive hidden layer until we arrive at the output. Similar to forward propagation, we have backward propagation. Now, if we just reverse it, if you follow the red arrows in the picture below, you will notice that we are now starting at the output of the magenta neuron. That is our output activation, which we use to make a prediction and ultimate source of error. in a model. We then move this error backwards through a model via the same weights and connection that we use for forward propagation arm signal. So instead of activation 1, now we have error 1, the error attributable to the top blue neuron. Now Mayuresh will take over.
Thank you, Hemant. So far we have seen basic components of deep learning, its applications. Now let's deep dive into the application side of deep learning. However, I'll first introduce uh, you guys to one of the deep learning frameworks that we'll be using at the end of the session in the live coding demo. So TensorFlow. Uh, TensorFlow is a deep learning open source framework which uses data flow graphs for its mathematical computations. It is a complete open source library developed by researchers and engineers working at Google Play. In the introductory slide, I mentioned about something called data flow graphs. So, what actually data flow graphs are? So, in the slides, you can see at the left hand side, there's a code written, and the right hand side represents the graphical interpretation of that code. So in the first three lines of code, you guys can see we have declared three tensors. So the TensorFlow compiler is taking those lines of code and then it is converting them as a node for a graph. Then at the fourth line of code, the last line, we are computing a bunch of mathematical calculations. Uh, so it is actually deciding the flow in which our nodes will be passed to further nodes. So here W and X, we are first taking the matrix multiplication of W and X. So the W and X nodes are pointing towards the matmal operation. Then the result of the matrix multiplication will be passed to the addition node along with the bias parameter, and then again its result will be passed to the final layer of our graph. So basically, what TensorFlow compiler here is doing is it is converting human readable high level code into machine readable directed data flow graphs. So the major advantage of these data flow graphs are they can be computed parallelly. So this increase in speed is exponential. So the nodes which you can see in the graph are computational units, and the edges with which they are joined together are basically the data consumption or the result that the computation step is performing. And these graphs can be executed by either GPUs and CPUs. So we can train our models faster and we can converge our models faster. Next slide. So now let's talk about the history or the development of TensorFlow. So TensorFlow initially was developed by the Google Brain team for the internal purpose use. So it was not open sourced until 2015. So in the year 2015, Google decided to open source the TensorFlow, and with its initial release 1.0. Since then, there were a lot of changes, major changes that were made, and in September 2019, Google announced TensorFlow's next major release as TensorFlow 2.0. Currently, the stable version is 2.8 and is continuously under development. The community which is working on TensorFlow's development along with the Google's team is really amazing. Some of the major commits that were made to the TensorFlow repository are from non-Googler contributors, which includes but is not limited to the GPU support for Windows. So this commit was one of the major commits that that was committed back in I think 2019 itself. But the contributors were non-Googler. So the community is amazing. So there are a lot of different deep learning frameworks available out there, each having their pros and cons. So I'll be talking here about why TensorFlow. So one of the first things that come into my mind is that well-written documentation. TensorFlow provides a neatly written documentation where you can find anything without any hassle, and everything is written perfectly and is self-explanatory. So it is awesome. Plus, as I mentioned earlier, CPU, GPU, and TPU support are also provided with the TensorFlow, and the cross-platform capability of TensorFlow is also one of the major highlights. Then, distributed training on clusters for large models or data is also possible with the help of TensorFlow. High scalability ensures smooth workflow in production environment, so you need not to worry about manually scaling or managing your apps. So, one highlight that we'll be talking further down this session will be uh, building your model in minutes. Like literally, you can build your model from scratch in few lines of code and in very short amount of time. TensorFlow supports a wide variety of languages, although TensorFlow has APIs available in both the languages for constructing and executing a TensorFlow graph. The Python API is at present the most complete and easiest to use, but other languages APIs may be easier to integrate into projects and may offer some performance advantages in graph execution. Although other APIs doesn't guarantee stability and hence provides some backward compatibility. So basically, Python, C++, and JavaScript languages are quite suited for TensorFlow, and other languages such as Java, R, Go, Ruby, Scala are still under development, and community is constantly working on it. But as I mentioned earlier, it provides some backward compatibility. So TensorFlow ecosystem, like when we talk about TensorFlow, it is worth mentioning the ecosystem that it takes with it into the market. So TensorFlow is not just one entity, but it comes with a whole bunch of different tools that help machine learning engineers and professionals to push your systems into production. So it contains a wide variety of tools that helps developers to take their models at production level in a hassle-free way. So these are few components that I have listed here. So basically, TensorFlow Lite is used to create light models, that is uh, performance-related models, increased throughput, increased reliability, to ensure that our model is running smoothly on edge devices or embedded devices, which are actually low-end devices. So it is very awesome tool. TensorFlow Hub is kind of TensorFlow model garden, you can say, where have researchers have put their state-of-the-art models. And the awesome thing about TensorFlow Hub is that it is completely open source, so anyone can just grab a model and apply it in their use case. Coming to TensorFlow Quantum, so basically TensorFlow Quantum is a library used for rapid prototyping of hybrid quantum classical ML models. TensorBoard uses a visualization tool which helps a lot while building the projects and even in the production environment. You can set your TensorBoard to track your different pipeline performances and different kinds of um, maybe metrics that you are interested to know about the data shift or the data drift. So it is a very awesome tool. Finally, TensorFlow Extended is a library which is the backbone of, you can say, production level deployment. So TensorFlow Extended is built on top of many different libraries that are included within TensorFlow, such as TensorFlow Model Analysis, TensorFlow Data Validation, etc. So TensorFlow Extended basically provides an interface, or you can say you can create pipelines using TensorFlow Extended. So you can take your models from your development environment to the production environment. And as I said, it is highly scalable and really awesome tool to get into production. All right, so we are done with the theoretical aspect. Now I'll share my screen and we'll go for a live coding demo. We'll not be doing anything crazy here. This is just you can say a hello world problem in deep learning. So I'll share my screen. I hope my screen's visible. Just give me a heads up. Yeah, sure. Okay, so let's start. So our problem statement here would be something like we have given a bunch of uh, images, handwritten images, and we have to classify them in order to make some predictions. So this dataset is called as MNIST dataset, and we'll be doing that. So I'll encourage you to code along with me, so you'll get a better understanding of what is actually happening. So let's start. I'll first start by importing TensorFlow. Okay, so we have gathered the project dependencies. Now we'll get our data set. So as I said, we'll be using MNIST dataset, and TensorFlow's Keras API provides a bunch of different built-in datasets. So we'll be using the same. So I'll just load into it. We've gathered the data. Now this part of code is not actually building model, but I just want to show you that how our data is actually looking. So what is present in our data? Like I've told you that the data is related to a bunch of handwritten digits, but what the data actually looks like, I'll show you that. So this is just a utility function. We are not doing anything crazy. So let's start. We'll be taking a look at let's say six images. Let's say six images. Let's go for six images. As I said, don't worry about if you're not following through, but this is just a utility function to um, see what our data sets look like. All right. So as you can see, these are handwritten digits, and our task is to just classify these. Uh, like we have to tell if we are going to pass this image, then we have to tell that okay, this image it corresponds to the number 8. So this is our task. All right. Now, the important part. Now we'll build a model from TensorFlow scratch using the functional API that Keras provides, and we'll be then passing the inputs and outputs, the intended inputs and outputs in the tf.keras.model class. Let's build. So I'll first specify that what input shape I'm looking at. I'll tell you why I've chosen this shape in a moment, and how do I know that this is the shape of the above presented images. I will show you everything. Just hang on there. This flatten layer will just take the our image, and it will squeeze all its dimensions into one single dimension in order to pass it to further dense layers. Okay, so now we are entering a really interesting stage here. So basically, now we are going to choose some arbitrary constant number which represents the units in our hidden layers. As you have seen earlier, these hidden layers are private to it, the neural network, and the units that we are going to choose, and even the activation function are all hyperparameters. So there is no ground truth that okay, this number will be better. You just have to explore. You just have to experiment with all the different kinds of you can say permutations, and just select one that is working best in your scenario, right? So let's say I'll start with 128 nodes, suppose. Fine, and activation function I'll use value. I'll pass the output of the previous layer in. Again, a dense layer with suppose this time 64 nodes in it. Okay, so now after this dropout layer, I've used something called as a dense layer. I've used something called as dropout layer. So basically, what dropout layer is doing, it is just picking this probability like 30%. I've passed 0.3, which corresponds to 30%. So it is going to hide 30% of this hidden nodes from the next layer. So this step is done to ensure that there is no overfitting of the model, like to increase the performance of our predicting model and increase the predictivity of the model. So dropout layer is minimizing the bias towards certain classes, and it is going to converge faster and reduce overfitting of the model, if any. Right, now it comes output layer. So let's see. Right. So as I said earlier, this number of units is completely arbitrary constant. It is a hyperparameter tune, but in the output layer, we have to match the use case that we are using. So here we have to classify the digits from 0 to 9, right? So there are possibly 10 cases that we are looking at. So if I'm going to pass any image to the computer, it can be 0 to 9, anything. So we have to look upon 10 different classes. So in order to do that, I'll be specifying the number of nodes in the output layer as 10, because there are 10 different classes in our scenario, right? And activation function will be softmax here. So basically what softmax is doing, softmax will return the probability distribution that the model is predicting over the 10 different classes. So our model will be selecting the highest probability distribution of the class, and our model will say, okay, so this class has highest probability distribution, so it corresponds to that specific class. Okay, so as I said earlier, we'll pass these inputs and outputs to the tensorflow.keras.model class to build our model. can just give any name to it and just return the model. Now I'll call it. Sure. Let's see some insight of the model by calling the summary function that the TensorFlow Keras API provides. Okay, so as I specified my name of the model, it is appearing here, and here you can see a bunch of different information about our architecture of the neural network. So basically, the input layer has these many shapes in it. The data which is going to be ingested in the input layer will be of this shape, and you can see how our inputs are progressing through different layers. So it is changing its shape into different forms, and then finally we are predicting the probability for 10 classes. So you can see entire flow of our data through the model by using this summary function. Okay, now as I said earlier, I have specified here the input shape as 28 by 28 by 1. Okay, right? So now let's see what actually currently our data looks like. So let's see. Okay. So in the X test, the testing set, we have 10,000 samples, each of 28 by 28 pixels. So as you can see here, there are images. So these corresponds to pixels and they are grayscale images, but we have specified here as 28 by 28 by 1. So I'll be reshaping this tensor to this 28 by 28 by 1 shape to ensure that my input size is compatible with the model. Okay, so let's do that. So basically TensorFlow.expandance just expands one dimension wherever you will specify. So I'll pass my test and I'll here normalize the data by dividing it by 255, because the maximum number that you will encounter when you are dealing with pixels is 255. Therefore, I'm just dividing the entire tensor by 255. So our maximum will be 1 and minimum would be -1. So the entire data set has been changed from 0 to 255 to 0 to 1. Okay, let's now specify where to add the axis. -1 represents at the last. So -1 is okay. Same will do for training set. All right. Now we'll inspect again shape. Now, as you can see, our training set consists of 60,000 examples, and we have reshaped it from 28 by 28 to 28 by 28 by 1, which is compatible with our models input unit. Now, if you're confused about this none, basically this none is representing the batch size that we are going to feed into our model. So usually we don't specify the batch size here. So we just specify what our one instance of data look like. Okay. Now it's time to compile our model. So we have already built our model. Now it's time to compile it. So compile method actually takes a bunch of different parameters that you have to choose what optimizer you will be using for your back propagation, what loss function you will be using, what metrics to track while training. So these are again kind of hyperparameters. You can experiment with them. Let's see. Okay, so in this case, I'll be using Adam optimizer. You're free to use any different optimizer which suits your model. So you have to again experiment. Deep learning is all about experimenting. Let's see, loss function, TF. So Keras classes, Keras API actually provides bunch of different loss functions as well. You can again walk through if you want. I'll be using sparse categorical entropy because our training shape is going to fit in that, because the our target labels are sparsed and we have different classes, right? We have 10 classes to classify into. That's why I'm using categorical entropy and sparse, because our training labels are sparsed. And finally, the metrics. We'll be looking for the matrix here. Look, okay, everything looks good. Now it's time to train our model. So the first step was to build the model. Second step was to match the input layer, input shape of the data to our model. And now comes the final part, which is training of the model. It looks good to me. Okay. I'll be explaining about each and every parameter that I've passed into the model. So the X train and Y train are the the data and the label that we will be training our model on. The batch size parameter is specifying how much data at once we are going to send to our model for training purpose, in order to back propagate and use the gradient descent to optimize the weights. So we are specifying 64. So our data will be sent in the batches of 64. Epochs represents how much loops you want to run through for your training process. And the validation data is, you're just validating your model's performance on unseen data. So basically X train and Y train will be seen by our model, and the X test and Y test data sets are basically unseen by our model. So we are just testing how our model is performing. All right, I think I've mentioned everything. Now let's try to run it. Let me see. Oh, okay, I've missed an S here. No problem. All right, so this will take a while, but I'll suggest you to just take a look at these metrics that are being calculated here. So loss and the accuracy. So as you can see, our loss is decreasing and decreasing by the epoch. So our model is actually learning, and you can see accuracy is also increasing. Okay, so our model has been trained now. With the final accuracy we achieved was 98%, and on the validation data set we are close to 98%, 97%. So this is a good scenario where you can see I've written very few lines of code here, and even like this function was just a utility function just to visualize what kind of data is being presented. And still, I mean, just even in I think 15 to 20 minutes we have completed this, and you can see how much faster it is to build your models from scratch, uh, given a data set. And it is really really awesome. So you can see the final accuracy is 98%, and it is quite good performing, right? So I hope you enjoyed this little tutorial, and this will hopefully build your interest in getting into deep learning. There are a lot of different applications of deep learning. This was just a hello world program uh, in deep learning, you can say. So now I'll transfer the control to Hemant again. He'll be showing you the simulations about the neural networks. Thank you.
Um, Thank you, Mayuresh. Okay, so here this is a small simulation of how a neural network actually looks and how it actually works. This is so basically may before while making any neural network we specify some parameters. So these are three parameters, three main parameters which we specify. This is the epoch as explained by Mayuresh. Epoch we can simply understand as imagine we have a data set of 1,000 images. So an epoch would be like when the model sees all the 1,000 images once. And so if the data set if the model sees all the 1,000 images twice, it would be two epochs. Learning rate is the number of corrective steps it is the model is taking to reduce the error. And act and activation function is will tell the hiddenness how the model will train on the training data set. So these are the four data sets. You can select either of them to input for the model. These are the features. So which we want to feed in. These are the hidden layers. You can try increasing and decreasing the hidden layers. You can add more neurons to it and see how each of them perform on this data set. So while if you can see how you can see that loss is decreasing as the number of epochs are increasing. You can play around with this site. It's a pretty cool site, and you can also learn how a neural network works. Hmm, let's try another data set. So you can see the loss is increasing as the epochs are increasing. You can also try some other activation function, and you can also try regression problem for this. So this is a small simulation. Now I'll pass to Ayush.
All right, so that brings us to the end of this whole session. Uh, I hope you guys enjoyed it. We'll just talk a little bit about the projects that we have been doing here at GDSA. So, Jackson, I'll request you to go ahead and get started with that.
Yes, sure. Is my screen visible? Can anyone give me a heads up? Okay, great. So I really hope you guys found the session enjoyable. It should be a basic pathway for you guys to get started with deep learning. And now to talk about some of our projects that we created. So this is Medicare. It is basically a ML-based web application that will bring standard data sets like breast cancer and diabetes into life. Now, by into life, I mean is we would create an interface where a user can input data and they could get predictions in real time. And it won't be a Jupyter notebook or a Google Colab where they have to um, put in values using an array. It will literally be an interface. It will be a HTML form. So as you can see, we have used Python, JavaScript, NumPy, and Flask. Flask is basically a micro framework which is built with Python, and it is used to host machine learning and deep learning models. And we have taken the breast cancer and diabetes because as a beginner in machine learning and deep learning, all of us have been told to use these two data sets because they are very easy to use. And here we have described the algorithms that was used with the accuracy. And here is the demo. So as you can see, there's a form. You put in values inside it, Like in this, we will be selecting diabetes prediction, and yes, as you can see in the demo, it has a form and it will input values into it. And after clicking the predict button, you will get to know if you have breast cancer or not, if it is benign or malignant, etc. This project is open for contribution. This project is very well documented, so you can follow steps which is given in the code, and you can create your own APIs. So the link to this repo would be given in the chat, so you guys can fork this repository, make your own predictions on other data sets. Like you can do kidney disease classification, for example. It can be a CSV file based or image classification based. It doesn't matter. The code is very well documented, hence you will have no issue to link your model with the Flask application. Apart from this, we have other projects that we have worked in GDSCVIT Bhopal. Ayush, could you explain that?
Yeah. Can you just pull up ML Reserve for me?
Sure, sure.
Yep.
Here we go.
All right. So this was a project that we built during the Hacktoberfest, and to which the contributors were contributing during the whole month of Hacktoberfest. This is an open source project, and the basics of it is that anybody who has built any deep learning model, machine learning model, can come and contribute to this repository. You learned how to build your own model today in the live session. Mayresh walked you through every step. So go ahead, give it a try. Build some cool models, and feel free to make a PR to this particular repository. As Jackson mentioned, all of our repositories are properly documented, so you will have no trouble contributing to it and following along. And yeah, I think that's pretty much it. There's another project that's coming up that we are working on, and once that is live, it will also be open to contributions from you guys. So yeah, basically that's pretty much it about the whole episode 2 of ML Talks. We are open to any questions that you have, so feel free to put your questions down in the chat and we'll try and answer them.
You can ask us anything, guys. Just go on with it.
All right, so I guess we have no questions related to the session. So yeah, I think that will be the end of this particular. Oh, we have a question.
Ayush, we have a question.
Yeah. How to get started with ML, and how much time does it take to become a master or even an intermediate level ML coder? Well, the ML team, anybody would like to take up this question? Because I have pretty much answered it quite some time. I think you all should answer it now.
Sure. Actually, uh, the path that we follow is quite like it is subjective to you, what you want to get into. So if I'm going to talk about my personal experience, I started I think in 12th standard something, and basic ML and the math behind it is really important, right? You have to go through every mathematical concept behind machine learning or even deep learning algorithms to get perfect insights of what actually is happening behind all the fancy frameworks that we explained and everything. So I would say it really depends upon you what path you have to follow, um, what kind of level you have to achieve. But yes, just give it a try. And mathematics, I would again say it is really important. Just cover both the aspects, balance it. Application and the theoretical mathematics is really important. So, answering your question, it really depends upon you how much you will grasp in time.
Regarding the second question, that where would you rather start practicing to gain experience? You should start practicing in Kaggle notebooks. Like, you should see the notebooks that the and sort it by votes, and follow that to gain a greater experience. Also, like, you could refer to some of the GitHub repositories to see the uh, previous done previous work done by some of the reputed personalities from the industry. And obviously, Kaggle is the best platform to get started with ML and practice.
All right. So the last question that we have is, what about the ML in Tesla? Can you explain it briefly? So to be honest, the type of ML that is used in Tesla would be something of so they have automated cars, right? So one of the applications can be a pathfinding thing. So what they do is they have an autopilot feature where the car navigates the roads and streets on its own. So that they do by basically finding a right path, and then they have a bunch of sensors around. So you're combining IoTs and everything, and whatever input that you're getting from the sensors, this data goes back directly to the car, to the servers. From there you get the feedback of whether you are safe to take a turn or not, or whether you can move ahead in the same direction at what speed. So there's a lot of stuff that goes on behind the scenes. And yeah, that's I think that's pretty much what goes on behind ML in Tesla. You can read more about it in articles and blogs that you'll find on Google. So yeah, this is what I'm aware of as of now. Can you explain mathematics? When we talk about mathematics related to machine learning or deep learning, there is linear algebra, there is statistics, calculus, and yeah, I think that's it. Am I missing something? A little bit of discrete maths, I guess. But apart from that,
Probability.
probability, yeah, probability and statistics. So yeah,
Probability,
that's
yeah.
one thing. Yeah. So that's pretty much it. Those are your pillars for learning machine learning. Don't you What you can do is you can get decent at all of this, like understand what these are, and like what are the basic concepts in linear algebra, how do you work with matrices, vectors, and stuff like that. And I think you are pretty much ready to dive into the algorithms and stuff where you need these mathematics. You can work on differentiation better, instead of working more on integration, work on a differentiation, because differentiation is something that you'll see more and more, like partial derivatives and stuff, when you study the maths of backpropagation and stuff like that.
Also, to add to that answer, you could check out the Discord server of GTSC Bhopal. We have tons of resources
Yeah,
in terms of mathematics used for machine learning and deep learning. So feel free to check out the server.
yeah. Um, Another question is, if I want to increase,
Uh,
Nairish, would you like to answer this?
yeah, sure.
Yeah,
So speaking about super sampling, there are a lot of different algorithms available. You just have to, go and search for them towards data science and medium are right place for it, and you will find a bunch of different, mathematical explanation blogs of super sampling techniques and how to improve the quality of images that you're passing to your TensorFlow, any neural network. So basically, this demo was only based on the modeling part. So this everything is comes under the pre-processing steps, and it is a huge domain. So everything cannot be covered here. But yes, I'll suggest you to just go Google on towards data science and medium. It will help you a lot.
all right. Another question that we have is, how to use Kaggle efficiently. To use Kaggle efficiently, all you need to do is just go ahead, pick up a data set that you like. Kaggle has a lot of data sets out there. So just pick up a data set that you're comfortable with, or that you like, or that you think you will be able to work better with. Just start making notebooks, start experimenting with a lot of things. As Mahesh correctly said, that deep learning is a lot of experimentation. So yeah, experiment a lot, and yeah, the forums on Kaggle where you can ask people questions, and yeah, you can actually get it answered from someone who's actually a data scientist working in the real world. So make good use of that, and yeah, just keep practicing on Kaggle. There are tons of data sets, so you will have run out of data sets to practice on. And yeah, take part in Kaggle competitions. Again, very helpful. And yeah, that's pretty much that you need to. That is how you can use Kaggle efficiently. Do we have any further questions? All right, I think that wraps it up for us today. So, yeah, this is the end of episode 2 of ML Talks. Thank you, folks, for tuning in, and we'll be back with another episode soon. You can find all the important links in the chat itself, and later on in the description of this video. So, yeah, thank you, folks, for tuning in, and we'll see you in the next one.